My name is JJ Asgar, and I'm a developer advocate for the IBM Cloud. Thank you for joining me today. Hopefully you'll learn something. I'm going to be building a small Python app on OpenShift or Kubernetes in this presentation. I'm going to start with some slides to kind of just show off the ground up from there to be able to have the vernacular. So when I start talking about things, it'll make more sense. If you've never seen Kubernetes or OpenShift before, this is a great tutorial. Otherwise, hopefully you'll learn something that you don't already know. So let me transition over to my desktop now. There we go. Wonderful. Hopefully you can see my slide now. Kubernetes, OpenShift, and way too short of a time. And again, hi, JJ. And I do have that email address of awesome@ibm.com, or you can find me on Twitter is @JJAsgar. Okay. So let's talk about some building blocks to kind of start the conversation around how Kubernetes and OpenShift come together. First thing first, we need to know about containers. Containers are either in really one major flavor now, which is adhere to the spec of OCI, as you see on that second dollar point. Now, there are multiple different offerings and ways to work with that spec. There's something called Podman from Red Hat. And then there's Docker, which is in essence, the Kleenex, if you will, of the container world. There's also things called Builda and Canico that allow you to build these containers without having the actual container runtime, which is really important in secure or other environments. A container is just a wrap around a process. So it is the smallest entity that is ran. Every container needs a registry or somewhere to store it. For instance, Docker, Hub, or Quay. They're built from something called a Docker file, which we will see here in a little while. And then the beauty of containers is that it's a package and run anywhere, as long as you have the container runtime. Now, this is that old joke that it works on my laptop. Containerization allows you to do that. If it works on your laptop as a container, it can run anywhere with the container runtime. So as you start building up applications, you need some way to orchestrate this. So that's where Kubernetes comes into play. In essence, it's just a massive container orchestration platform. It is open source and community supported. There is no long-term support because it's an upstream project with its own governance model. There are certifications for different platforms, AKS, EKS, GKE, and of course, IKS and IBM Kubernetes Service. And there's limited security and a core framework. It's a very small groupings of things to do it, and they allow the ecosystem around it to take care of most of it. The platform and the user are responsible to integrate beyond just the core orchestration layer. There's multiple different choices to go for, and it is very, very bare bones when you actually look into it. But that's by design because they want the ecosystem to do it, not the major project. Now, if you notice, because I called that community support specifically because on the flip side, on the enterprise level, there is a production grade open source platform called OpenShift that is built with Kubernetes. So if you imagine OpenShift is not on top of Kubernetes, OpenShift is Kubernetes with a lot of very strong opinions on how to interface with it and also enterprise support. So if you're an enterprise looking for the cloud native ecosystem, please take a moment to look at OpenShift because it will actually, there are some huge advantages to going whole hog into it. I'm going to show off some of the advantages today, but the beauty of it is that if you imagine me using this, it is just Kubernetes. It's just with the interface of OpenShift on top of it. I want to also make sure that you realize there is long-term support with OpenShift, unlike upstream Kubernetes, because it comes from Red Hat, and Red Hat is infamous for their long-term support. Okay, so let's talk about some very simple concepts to be able to kind of bring everything together. So when I start actually hacking on the code here in a little bit, you understand where I'm coming from. First thing first, so as you see here, containers are sitting inside of a pod. The smallest thing, Kubernetes or OpenShift, I'll use those terms interchangeably, but I will call out specific OpenShift things when they do show up. The things you see here, containers fit in something called a pod. Pods can have n number of containers, where n equals 1 plus whatever number. In this case, pod A has 2 containers, pod B has 3, pod E has 1. When you tell Kubernetes or OpenShift, hey, I need to make sure that number of pods are running, that's something called a deployment replica. As you can see here, pod A has a deployment replica of 2, so that will always make sure that Kubernetes or OpenShift will always make sure that there are 2 pods of pod A running. So that's how you declare it. It's desired state using the API to talk to it. Now, importantly to know, when you have these deployment replicas and these pods running everywhere, everything runs off something called a node. A node is just a CPU, or it's just a machine that can hold it. It can be bare metal, it can be VMs, it can be even your laptop. It doesn't really matter, as long as it has something called a kubelet and can talk back to the main controller nodes of Kubernetes. So in essence, if you are a consumer of Kubernetes, you don't even know where it actually runs. It's just an API to compute to the Kubernetes or OpenShift clusters. So in essence, as this diagram shows, everything is just Kubernetes and OpenShift. Nodes can be anywhere, as long as they can talk to the control plane. So let's talk about some internal concepts of Kubernetes, also known as K8s, and OpenShift, to make sure that as you see how it all comes together, why there are some advantages that we have here. All right, first thing first. So if you imagined you have all these pods running applications or services or whatever, they need to be able to talk to one another. So inside of Kubernetes, there's something called kubedns, which allows for service discovery. So if you imagine here with pod A looking for foo web, when you declare a service, as you see on the far right-hand side, and you say, hey, foo web point to pod C port 5000 on port 80. So as you can see, port 80 is sitting in foo web, and then it hits 5000 there. Now, most importantly to know, this is only internally inside the Kubernetes cluster. There are ways to expand it outside, but that's out of the scope of this conversation. I just want to make sure that you realize there is a DNS service inside of Kubernetes, and there's a way to create services to point to the different things, so people kind of, all the different processes and pods can talk to one another. Next important thing to know is something called namespaces. I bring this up very early in the conversation to make sure that you realize the namespaces are insanely powerful and allow you to actually do some really, really cool things. Specifically, if you notice here, these are 2 exact same entities of your application and my application. They're the exact same foo web, exact same containers and everything. But because they're inside of namespaces, in essence, it's a walled garden where my application on pod B cannot talk to, or in most cases, cannot talk to pod B on your application. There are obviously caveats to this, but the purest sense of the way of saying it, namespaces really are walled gardens for applications. Now, the most important thing to realize from that is that you could run dev, QA, and prod all inside of the same Kubernetes cluster, which allows you to stamp out exact same infrastructures on all of them. They can't talk to one another. Maybe you have a prod database over somewhere else and a dev database locally or something like that. So you can actually make sure that you run on the exact same hardware. The story goes of, how every QA environment is always a stripped down version of prod. Well, in this sense, by using namespaces, you could use the exact same hardware and just shave off a portion of it to be able to go for what production has too. Obviously, there's a lot more caveats there, but imagine in that. You can share your hardware, which for an old sysadmin like me, that's a pretty big deal. Now, in the OpenShift world, they've actually taken it one step even farther, and that's something called projects. Now, unfortunately, for some reason, my little X's didn't show up here. Hopefully, you can see my mouse. There are an X here, and X here, and X here. So let's just take, for instance, I'm running the payment dev project. I have no need to talk to payment prod because I'm trusting that my production engineers are pushing things out to production. So I only have access to this specific project inside of OpenShift. Now it extends it to allow it to do cross environments, teams, and groups, because OpenShift has that capability of the interactions around it. So you can actually have permissions that go across the board, which is very, very strong. One of the tricks that I've been told by some of the people who run OpenShift in production is that, believe it or not, when you're actually doing development work on OpenShift, one of the best things, a way to think about a project, is kind of like Git branches. They're ephemeral. They're only supposed to be short-lived. where you have the master branch of payment prod here, but you might have payment dev today's date time, yesterday's date time. So you can iterate quickly to make sure to see how it is, because projects can just be created and destroyed willy-nilly, which allows you to get to where you need to be, and then you can promote it to prod very, very easily too. Obviously, you wouldn't want to have multiple days of prod, but you kind of get the point. It's if you kind of imagine it as Git branches, all of a sudden things become a little bit easier to understand. Okay, so we had that service that actually talked about how to get to foo web, and we hard pointed it to that port 5000 on pod C. Next one here is something called a load balancer. It's just like the load balancers you used to use on your servers or in your data centers. It's just inside of Kubernetes. The beauty of it is there's a ton of knobs and dials to do it, and you can expand horizontally as far as you need to go with a load balancer. So when you hit port 80 and you have the type of load balancer, it will make sure that it hits any versions of pod C, as many as it needs to be. I strongly suggest looking at docs.kates.io to look at all the bells and whistles and the knobs and dials for it. And there are ways to actually strip out the load balancer services and put in something like Nginx or something else along those lines. It's well worth your time, especially if you're planning on going into this ecosystem. The hardest concept to understand inside of when it comes to networking, or honestly, all of Kubernetes, is something called an ingress. An ingress is basically the declaration of how your app works inside of your Kubernetes cluster. So let's just take a quick, really bad example, but this is how it kind of matches up. This ingress over here on the right-hand side is a very shortened version of it, but in essence, as you see that HTTP path there, it says if you go to /, you need to go to foo web and then the port 80 of this pod C. But if you need to go to the data port or /data on this and you need to hit the foo data service, this goes over here. So if I was coming in from the outside world and I just wanted to hit the main website, I would go to /, it would come here, and then in essence, I'm going to this level of the pod or whatever. Now, if we actually had a bunch of data here that we needed to pull into here, because we have this ingress control and how everything's mapped out properly, when we actually do a get to foo data, it will go over here and talk to foo data and go to the correct pods there, which is quite nice. And there's nothing stopping me in this example. If I was coming in from the outside world, I could go to /data and I would go directly here too. There's a lot more nuance there, but I wanted to make sure that you at least saw what an ingress is and have a basic knowledge, so as we move forward, it makes more sense. Now, if you didn't notice that was all YAML on the left-hand side, and there was a ton of more things inside of it, but it was a very basic example. Inside of OpenShift, there's something called routes, and it turns out it's just literally one command, OC route expose and the service, I believe, and it does all that work for you. So you can come in with any major web browser and hit if you created that route, it does everything for you automatically. Automatically, if you want to play that joke. It's unbelievably powerful, and it makes life significantly easier. So you don't have to mess with those YAML files, let OpenShift do the hard work for you. Okay, so this is about 13 minutes in, which is great. Actually, 14 minutes in. So I've covered a good portion of what I wanted to talk about. So let's actually take this to the next step and see some code working on OpenShift. Again, I'm going to be talking about OpenShift specifically because there's some really neat plugins for it that if you don't take the moment to look at how this is, you're missing out. I will say all the code that I do run here can run also on Kubernetes. They're the exact same thing. It's just I'm going through the OpenShift path because it's worth the time to see it. Okay. Now, so here's my actual app, Cloud Native Python example app. It's very, very, very advanced, as you can see here. It says "Hello World." That's literally all it does. And there is a nice health check, but that's a little out of scope for this conversation. I do want to show a Docker file to make sure that if you've never seen one before, This is all it is, which is quite nice. Let me make that a little bit bigger. Right there. So as you can see here, we pull down the Alpine Python 3 container from upstream. We copy in everything into our app directory, which is a bad practice, but this is an example. We run pip3 requirements.txt. We put it in user 1001, and then we just run Python against app, which is great. And because we declared it inside the app, it'll know what port it is, et cetera, et cetera. Okay, so there's a couple different ways of doing this. And I'm going to first start with this very simple app. I am going to build it on my local laptop. And we are going to see the container running just to prove to you that, quote, it works on my laptop. Okay, so here's the code right there. It's the exact same thing. If I do docker build period tag code VMwareCode Python latest. Seems reasonable? Seems reasonable to me. All right, so I already had the container there. Now it's running the pip install against it, which is great. It's installing all the stuff it needs. It's complaining about something, and that's not a really big deal. Okay, so I know, as you can see, it is now tagged as this. So I can now split this there, so we can have this later. Do docker run dash run this with, and I need to put the port in there just so I don't forget. P 5000 5000. So what this does is it runs the Docker container, and then maps port 5000 to the Docker container internally to be able to do this. So the beauty of it is, if I do this right, there we go. So we actually see our Flask app running on port 5000, and it's listening on all ports or all interfaces. So if I do a curl, let me make this a little bit bigger for y'all so you can see it. Hopefully that's a little bit better. And yes, I am actually looking at the screen on the other hand side, so I'm sorry that I keep looking away from the camera, but hopefully you'll get this. curl-http://localhost port 5000. And this should say, hello world. And as you see, we get the get. Perfect. So now we have a simple Python app running Flask on my local laptop, containerized with the Python code latest, and it is good. We have done exactly what we want to do. Wonderful. Okay, so that's cool and all, but JJ, it works on your laptop. Great. We need to push this out to an actual cluster. And that's where I'm going to go ahead and talk about OpenShift. So here we go. As we see, we have OpenShift here. There's a lot of options here, but what we're going to do is we're going to build a container on the local registry. OpenShift comes with its own registry, and then we're going to deploy that application. And then eventually I'm going to get, I'm going to put some CI/CD inside of it. So we'll be able to actually do a push to our repo. And then from there, it'll build it and bring it out inside of OpenShift for us automatically. So let's take the first step here. All right, so I'm going to go over to developer. I'm going to go ahead and import from Git. And here's my Git URL. So I need to come over here to grab HTTP, copy that. There's a bunch of different ways of doing this. I'm just going to do it through the GUI because it makes life a little bit easier so everyone can see it. It's a Python app, which is great. That seems all reasonable. That seems reasonable. So let's go ahead and create it. All right. So this is us actually building it. As you can see, here's the build started. And we'll go to the logs. We should see pretty much the exact same thing we saw earlier, which is exactly what we're hoping to see. Come on, computer, do your thing. So while that's going, I'm going to come over here real quick. And one of the coolest parts about all of this is using webhooks. So I'm going to prep this webhook over here and add webhook and make sure I have this ready to go. So what we're going to do is we're going to actually add a webhook here as soon as this is done with the first build, which is getting close already. Then we'll set up a webhook so when we make a change and push it up, we will see the container be rebuilt and put together, which in essence is exactly what I was hoping to show you. Now, again, you can do most of this also with vanilla Kubernetes, but there's just not the happy path that we're walking through here. Okay, so that build looks like it finished. So let's go over to the builds here. Everything should look pretty good. Finished a minute ago. So let's go to topology, and there is our build, and we've opened that service. So if we click on our route here, because it's already created a route, we should see, no, something broke. Let's come over here, and this is the actual pod detail. Let's look at the logs. So it is looking at port 5000. Aha. So we have a problem with the service. It is looking at the wrong, see, as it sees port 8080, it's supposed to be port 5000. So let's make that a change real fast. I believe it is edit the service, and we see port 5000 to port 5000, and we save. As you can see, it should kick it. Go back to our topology. We should see 5000, 5000 here now. So if we go here, we don't see it again. That's unfortunate. Okay, well, I want to make sure I continue moving forward just to make sure that everything comes together. Normally, it is due to this port 5000. I am not 100% sure why that is not working how I want it to. Let me look one more time here. Nope. Maybe 5000. No. Okay. Well, let's keep moving forward. So if I come back over here and we go back to our builds, there are the webhooks right here. They already give you the webhook, which is great. So I'll do this, copy the secret with this URL. I'll paste this in here. It has a secret already built in, so I don't have to do anything there. We're going to just do everything here, and I'm going to add this webhook. Okay. This is being angry with me, so give me a moment. I'm sorry. There we go. As you can see now, we got a 200 back, so we now have the webhook set up to our cluster. So I'm going to bring this over here and hopefully not make this too hard to see. But the beauty of what I want to show is the builds here. So if I come over here and do app py, and let's say, oops, change this to VMwareCode. Git add period, git commit -m, added VMware code. Obviously, you should have done something better here, but this is just a demo, which is the beauty of it. Push. So now that I push this, oops, get pull, get push. Now, assuming this doesn't make a liar out of me, we've now pushed this up to our repo. And if you want to just see, we can go back over here, and we should see our master branch updated 28 seconds ago, added VMwareCode. If we come back over here, we should see a new build. There we go. Build is running. It will When it is done, it will kick our pod here. There we go. As you can see, it's now creating a new container, and now it's running, and we have our thing. What I'm going to do, just to kind of prove to you that this is it, there's a terminal, as you can see here, with this. So I can do curl http://localhost port 5000, and there you go. Hello, VMwareCode. I'm not 100% sure what happened with that route, but the beauty of it is we didn't have to do anything. You'd already created it, which makes life significantly easier. I am quite embarrassed that this did not work how I wanted it to, but you get the point. That's the beauty of demos. Things happen this way sometimes. Okay, so hopefully this has shown a good portion. A good portion of what I wanted to talk about. It is just a simple Python app, and it works now perfectly fine on Kubernetes, which is great. Or OpenShift for that matter. So I wanted to show this off in just a handful of minutes. And then let me go ahead and bring up one last slide here so we all can see it. Present. And come back over here. And I do want to say thank you. Thank you so much for having me. This is, thank you so much. This is a couple times I've done this now at VMwareCode. And if I ever can help, or if you're ever curious, please never hesitate to reach out to me at JJ Asgar on Twitter and awesome at IBM.com. Thanks. Bye.